Well, say somebody comes up to you one day and says, "Hey, can you solve this equation?" What would you do? Well, you'd probably say, "Luckily, I know the quadratic formula." Quadratic formula is this thing over here that involves a, b's, and c's. So let's take a look. The opposite of b plus and minus the square root of b squared minus 4ac all over 2a, where a, b, and c are the coefficients of the terms a, x squared, bx, and c. So the first thing I need to do is get this thing set equal to 0, so it's in the form that it's supposed to be in. So subtracting 2x from both sides, subtracting 1 from both sides, what I get is 3x squared minus 12x minus 1 equals 0. So my a value is 3, my b value is negative 12, my c value is negative 1. It's very important to get those signs right, otherwise you're going to get the problem wrong. So now I'm just going to apply the formula. The opposite of b is 12. Instead of negative 12, it's positive 12. Plus b squared is 144 minus 4 times 3 times negative 1. Whole thing is over 2 times 3. Big deal here is figuring out whether or not the part underneath the radical is adding or subtracting. Negative 4 times 3 is negative 12, times negative 1 makes positive 12. So what we really have is 12 plus or minus the square root of 144 plus 12, all over 6. And as we've simplified these things before, now it just becomes trying to simplify this thing. So what do we have? 156 and over 6. Now, ask yourself, what kind of perfect square goes into 156? I know if it was 160, it'd be pretty easy because there'd be a 16 in it, but I'm going to guess that there's a 4 in that thing. So I'm going to go and I'm going to give myself a little more space and continue this along and simplifying. So 12 plus or minus the square root of 156. Let's see. So I think we had 12 plus or minus the square root of 156 all over 6. So I'm going to simplify it by saying I think 4 goes in there. Let's see, how many times? 39 times? All over 6. So that's the same as 12 plus and minus 2 square root of 39, since the square root of 4 is 2, over 6. And since there's a common factor of 2 between 12, 2, and 6, I can reduce it a little bit further and say 6 plus and minus the square root of 39 over 3. And this is a perfectly acceptable answer. Some of you might have done it a little differently. You might have done 12 over 6 is 2, and 2 over 6 is 1/3. So you could have gotten this as an answer, and that's perfectly fine as well. So this would be 2 real answers, 2 plus the square root of 39 over 3, or 2 minus the square root of 39 over 3. That's because the part that's inside the radical is called the discriminant, and the discriminant being positive gives you 2 real answers. If that discriminant had been negative, I would have had 2 complex answers, and if it had been 0, it would just be 12 over 6, right? So if the discriminant is 0, then it would give me 1 real